Okay, now we're recording. Okay, good. Yeah, I would have forgot about that step. Okay, so first thing is there's another programming assignment now based on what we've been doing for the last year. We've been doing these examples. Okay, so this is the example, this is the example we worked on last time. No, I'm sorry. This is the one we did last time. Let's see. Okay, yeah, this is the example we did. So this is where we left off at the last time. Now, your homework assignment is to keep on going. Okay, so you've seen how we've been working on this in class. So now I want you to continue working on this example. So I'm going to close this and then I'm going to download the homework assignment now and let you see what I'm talking about. Okay, so homework assignments on this page over here. Oh, shoot, I forgot to upload this page, didn't I? Okay, so the homework assignment's not hard to find. Change 1 to 2, and it's there. I have to create a link to it after class. Okay, so there's the second homework assignment. Okay, so it's based on the example we just downloaded. There's the last version we wrote in class on Monday. So that's your starting point. Okay, now if you download the zip file that comes with the homework assignment, there's a demo version in there of what you're supposed to do. So unzip the homework assignment, and you're supposed to write this guy. Okay, now here's something a little bit interesting about the way Java works. This guy's a double clickable jar file. Okay, if you double click it, it runs. But there's something missing. The console window is not there. When you double click a jar file, it runs without a console window. This checkbox here is supposed to turn on debugging information so you can see some things going on, but it prints to the console. How do you get the console back? Well, the easiest way to get the console back is to launch the program from a command line. If you launch the jar file from a command line, you get a console window. So I wrote a little batch file to launch the jar file. If you launch the jar file this way, see, there's the console window. And then if I click on this debug output, see, I'm going to get debugging output here, which is going to help you when you write your code. It's nice to have some place to dump messages, print, so you can find out what's going on. Okay, so, but with the jar file, quite a quirky thing about Java is that when you have double clickable jar files, they run without a console window by default, but you can give them a console window if you write a batch script and launch them from the console window. So right now, the way that works is if you just look inside here, it's just a one-line batch file that runs the jar file, but that has the effect of leaving the console window open for us. Okay, so that runs by itself. This would run the jar file without the console window, but when I run it this way, I get the console window. So if you're at home and you're running this, you might notice that you can run the jar file just like that. But if you do, when you click on this, you won't know what it's doing. Right now, the system.out.print lines are printing to a phantom console window, and they don't cause an error or anything like that. They just print to nowhere. Yeah, it's just weird that Java works this way. But right now, the program's printing to standard out, and standard out's not there. Okay, so there's standard out's not there. But if you run it this way, now what this does is, remember, we keep a history of where the dot is. So if I turn on this debugging output, what I get over here is a list of all the what's in the history. Now I'm going to clear it. See, every time I move the dot, remember, every time I move the dot, it adds another entry to the history list. Okay, so as I move the dot, the history list keeps going longer and longer. Okay, so when we talk more about this assignment, you'll see that that can help you. That prints what you put in the history list. Okay, and then if you uncheck this checkbox, then the history, uncheck that checkbox, and then I gotta get okay, we've talked about focus, right? This guy responds to keystrokes. So that means he needs key focus. If I click on this checkbox, that little outline tells me the key focus is there. So if I hit spacebar, turns it off, spacebar turns it on, spacebar turns it off, spacebar turns it on. Any other key is ignored. That's important. Checkboxes, like the enter key, is ignored. The only key that's not ignored is the space bar, turns off and on the checkbox, and the tab key moves you to the next focus spot. These three are what are called radio buttons. Radio buttons, like, you know why they call them radio buttons? You guys know?
Because you can only have one press at a time.
Yeah, like the old-fashioned car.
Yeah, almost like an old-fashioned car radio or like a cassette player.
Yeah, when you press one button, the other button would pop out. Old-fashioned car radios are like that. Yeah, so you press one button and then the other button, or old jukeboxes and those things. They're called radio buttons. If you press this one unpresses. They're in a group. So if I hit tab, I don't go from here to here to here. If I hit tab, I go from here to the reset button. Okay, so watch. The tab takes me to the reset button. Shift tab takes me back down to here. Now, this is a group. What moves me in that group? The arrow key. So the arrow key is going to move me within this group. And it changes the background color. Okay. Now, tab takes me up here. Then tab takes me here. Then tab takes me here, 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 here. Now, this is a combo box. This is just like these guys down here. Now, the arrow key, except here it was the left and right arrow key. Now it's the down arrow key. The down arrow key lets me change in there. See, white, black, blue, green, up arrow, and down arrow. Okay, so now I'm in the blue color. Now, tab takes me out of that cycling back into where did it take me to? Oh, now tab took me to here. So now I'm here. Shift tab goes backwards to the, I can pick another color. Enter selects it. Tab takes me back here. Okay. Shift tab takes me back up there. Arrow key moves me to a different color. Enter selects it. Tab takes me back to here. Okay. Right. So these are called focus cycles. There are 3 focus cycles here. There's the focus cycle that goes button, button, slider, button, 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 slider, checkbox, 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 drop-down list, panel, button, checkbox, checkbox, group. Okay, that's a cycle. Then within that cycle are 2 subcycles. This is a subcycle, and the combo box is a subcycle. Tab takes me through the outer cycle. When I get to this guy, the arrow keys take me within the subcycle. And when I get to this guy, the arrow keys take me within the subcycle. Okay, that's how focus stuff works. So this is a more complex GUI. This GUI's got 2 subcycles within the bigger cycle. You're gonna have to look up how to build a radio button. Okay, and they're called a radio button group. And if you look at the homework assignment, I give you a link to how to make radio buttons and radio button groups. And I also put a link to that inside the zip file. inside the zip files how to use radio buttons. Okay, so I try to give you pointers to the things I think you'll need to know. So there's how to use a radio button. The combo box is another thing that we haven't used before. So I thought I put a combo box in here. Pardon me?
I said there's a link to it in the homework page.
In the web page there is, yeah. So like here, how to use combo boxes. So you have to, part of the assignment is you have to learn, you have to read the documentation, look at the example code, figure out how do you build a combo box, how do you build a radio button group, okay? All right, so now what else is in this assignment, okay?
One of the things that I'm noticing is when you change the color, the entire trail changes. Are we gonna have to set it so that the trail stays the same color when we colored it, or?
Well, there's this color history.
Ah,
So we did that. We were working on that when we quit. So you have to finish that. So, and then there's also the color width history. So like now if I go like this, if I turn on line history, it remembers the thicknesses. So it remembers thicknesses separate from colors. So you could turn off thicknesses, you can turn off colors. See, this one turns on and off color history. This one turns on and off thickness history. So now there's no, it turns off both of them. This one makes the pen go up and down. Now, one thing that's different between the one we did before was, the one we did before, you had a red dot drawing white behind it. Now the red dot draws red, the white dot draws white, and a blue dot draws blue. So it's a little bit different than the one before. So now I've got a red dot and it's creating a red trail.
more intuitive.
Yes, yeah, right. And so now a white dot creates a white trail. A black dot creates a black trail. You know, a blue dot takes a blue trail, except that if I turn on color history, it remembers what the colors were. Now, if I turned on debugging output, you'd see the history. The history for each dot includes its radius and its color. So each dot remembers what its radius was and what its color was. And that's in the history, but when you draw it, you can either pay attention to the color or not pay attention to color. So if you pay attention to the color, you color that dot that color. If you don't pay attention to the color, you color that dot the current color. So you have to have logic in there to choose between. And this button determines whether you use the color in the history or the current color. The current color is blue. There I'm using the color in the history. There I'm using the current color. Same with the diameter. This uses the diameter it's in the history. This uses the current diameter that's set by the slider. Okay. Now, then down here you have 3 different background colors. There's the original. That's the default background color we were using in the original app. Then there's a slightly darker background color and a slightly darker background color. Okay. This checkbox locks the screen. See, now it's resizable. This locks it. It's no longer resizable. Okay, that's kind of a dumb feature, but it's just, I wanted to fill up the screen with things for you to program. So I thought, okay, there's another thing for you to program. A button that locks the screen and unlocks the screen. So now the screen is a locked panel, and then you unlock it and you can resize the panel. Okay, so that's new, but this is useful. This is actually in there to help you so that when you're writing the code, you can click that and just see what's in my history list. So that can help you see if you're putting the wrong thing in the history list. Okay, this is just, again, this was just to get you to program a radio button group. Oh, see the underlines there? Do you guys like go to TextPad? Oh, let's see. Oh, they're not here. Let me look at Chrome. Huh. I just noticed something I've never noticed about Windows 10. Okay, so that's weird. I never noticed this before. Okay. Go back to this program. You know what those little underscores mean?
It's
A hotkey, right? They used to be all over. I mean, I just noticed TextPad doesn't have them anymore. You can probably assign them, but you used to see them. That means that what that means is you can use the Alt-1 key. Okay, so like here, the GUI, like right now, see, the GUI focuses over on that button there. Okay, if I hold down the Alt key and hit 1, see, it chose the background color 1. Alt-2 changes the background color 2. Alt-3 changes the background color 3. Those are hotkeys. They used to show up in like TextPad. It used to be in TextPad that every menu item would underline like a hotkey for the menu item.
Try hitting Alt first, because I know in one of the ways to make it smoother, like Firefox does the same thing, like it's.
So hit Alt first.
Yeah, and then it starts.
Then it turns on the hotkey. Yeah, thank you. I forgot about that. So you hit Alt key and it says, okay, now here's the hotkeys. So now, for example, V will take me to the V menu. Okay, so notice that turns on the hotkeys. Now over here, the hotkeys are turned on. They're just showed all the time. In this GUI, you're showed that that's a hotkey. Now you have to program that. You don't get that for free. So in the documentation on how to create a button group, it tells you how to assign hotkeys to the button group. I didn't assign hotkeys to any of the other GUI elements. So I assigned hotkeys to the button group. Okay, just this, those are the only ones that have hotkeys assigned to them. All right. The idea is to let you start seeing like all these little tricks that are part of GUI programming. Okay, so now, so here the hotkeys show up all the time. Let's see, what about Chrome? Okay, so TextPad, you have to hit the Alt key to find out what the hotkeys are. So Alt turned off the hotkeys, Alt again turns them on, hit Alt again, they turn off. What about Chrome? Does Chrome do the same thing? Is that
No, wow, that's annoying.
yeah, it's not. Whether maybe it's only maybe hotkeys aren't as popular as they used to be.
Yeah, I know Firefox does it, but.
Oh, there they're already on.
Yeah, I
See, yeah, they're just showing to you. That's the old-fashioned way to do it. So see the Alt now the Alt key highlighted it. So turn yeah, see how okay. Alt means that you're in the hotkey. So now if I type V, okay, now I'm see typing V doesn't do anything because I haven't turned on Alt key. So typing Alt shows me that I'm in the hotkeys now. So now I can use like T for tools. Okay, then down arrow. Okay. Tab will take me through now. Tab's taking me through, see, Tab is taking me through all kinds of different things. But Tab doesn't go back up to the hotkeys. Tab will not go back up to the hotkeys. To go back to the hotkeys, I have to type Alt. Now I go back up to, so Alt puts me in the tab, Alt puts me in the cycle, Alt puts me in a tab cycle up there, whereas the Tab key normally keeps me in a tab cycle down here. Okay. So the Alt keys, just it's nice to know about the Alt key. There are people who hate using a mouse. Yeah, there's people who can't use a mouse for disability reasons, and there's people who hate using a mouse. So these things are designed to be able to let you do almost everything without a mouse if you need to. Like for disability purposes, it's designed for people who can't use a mouse for some reason. And then there's programmers who just don't like to take their hands off the keyboard. If you're a really good touch typist, you can just fly through these interfaces without ever having to take your hands off the keyboard. You know, if you're really good at using the Alt, the tab cycle, the Alt things. Okay. All right, let's continue going through this GUI. Okay. Now, notice that, see that white dot there? That's so that you can tell which end of the thing is the end you click on. If that white dot wasn't there, see before it was a red dot that drew a white dot behind it, so you know what to click on. If that white dot wasn't in there, you wouldn't know if you were over here or in here or whatever. So the white dot is to highlight where you click. Now, what about when you want a white trail?
It turns to black.
Because otherwise you'd have a, yeah. Okay, so you gotta program that. You gotta, you know, if somebody chooses the white trail, you gotta make that little dot in there black, because otherwise you'd see white on white and you wouldn't see it anymore. And it really helps when you start going down like this. See, when you get to a really small trail, it really helps to have that dot there. See, it helps to have that dot there to click on, okay? Now notice that the red is gone now. So it's shrunk so much that the red, see, there's the red ring around the white dot. But the way I did it, it's a little bit sloppy. You know, you lose the red ring. Yeah, I don't care. If you can figure out a better, if you can make that better, go ahead. If you can make this a little bit better, yeah, right now the white dot stays the same size and the red ring just shrinks away. Yeah, it probably would have been better to have maybe a smaller white dot and left a little bit of a red ring around the white dot. Okay. And you know, it's same thing if you switch to some other color. See, okay. But if you do this, then if you switch the color, see, well, turn on the history. Now switch to. Okay, see now you see real clearly. I'm drawing in green. Okay, so now I know I'm drawing in green and I start there. Okay. And if I shrink the dot, I can still see where I draw from. Okay. Okay, what else? These buttons haven't changed. This resets the position. This clears the history. This changes the size of the circle. This is pen up, pen down. So you could do pen up, pen down. Notice that's still a history position. So if I want to get rid of it, I can clear it. See, okay, there's pen up, pen down. Line history remembers the thickness of the line. Color history remembers the thickness, the color of the line. This is new. You know, this is the drop down. This is new. This stuff down here is new. Okay, there's one other thing that's very new that makes this program really different. Okay, let me run the old one. I'm going to try to clean it up a little bit. Windows getting a little bit cluttered. Oh, one minor thing. Remember, we grouped these controls into a control panel, but we gave the control panel the same default color as the graphics panel. So you don't see the edge of the control panel versus the graphics panel. In the new one,
it's slightly darker.
Yes. Well, what is the control panel's got a background color?
Yeah.
Yeah, this is the default. This is the graphics panel. The graphics panel now has 3 colors, and there's and the control panel is a little bit darker than. So you need to you have to look up how you give a panel a background color. So now that way those control panels are distinct from the graphics panel, and you can see that it's slightly darker. The control panel slightly darker than the darker. How do you get the colors? If you want to match my colors, how do you get them? Yeah, use that color. Use one of those colored eyedropper programs. One of those things that, you know, go look. Use the exact same colors I use. Go look them up. You can. There it is. Okay, there's the color. Yeah, there's the color. Well, that's the color of this. The color of this guy.
Very similar.
Yeah, yeah. This is actually gunstock metal gray. This is supposedly gunstock metal. Yeah, gun metal gray or something like that. Okay, no, so it's not quite gray. It's a mixture. Yeah, it's a little bit of a mix-up of RGB. Okay, so you can get the exact colors you need by using one of these kind of programs. Okay, now here's a big difference. When you reset this guy, he resets to the same place. That's 300 pixels down and 300 pixels over. That was the center of the original screen. 300 pixels down and 300 pixels over. And it doesn't matter how I resize this window, it always will reset itself. Now see how the graphics is dropping away? I don't see it. Okay. And if I hit reset, it'll reset to the center. So, well, not to the center. It resets to 300 pixels down, 300 pixels over. Okay. The other one, let me reset both. Reset one takes you to the center of the screen. And it always draws. Notice that that thing is staying at the center of the screen. The drawing is centered in the screen. This drawing is absolutely, okay, the different terms we use is the drawing is relative to the center of the screen. So right now, that dot is at coordinate 0, 0 to me, because the center of the screen is my origin. I'm going to use a coordinate system just like you do in algebra. I'm going to put the origin right there. The origin is really over there in the upper left-hand corner. But I'm going to imagine, from the point of view of this program, that the origin is there. Then the trail is always going to be relative to the center of the screen. That way, when you resize the screen, the drawing will stay in the center. This guy is using what you call absolute coordinates. When you click on a dot, it records the actual pixel coordinates of where the dot is. Then when you resize the screen, it draws it exactly where it was before. So the drawing is in absolute coordinates. It starts off, if I quit this and start over again, that dot's in the center of the screen. But it's only in the center of the screen when the screen has the original size it had. If I expand this like here, see, it's no longer in the center of the screen. If I shrink this here, see, it's no longer in the center of the screen. It's in the same place all the time. 300 pixels. It's 300 pixels down, 300 pixels over. That's where it goes. So if I move it and I reset it, it's going to go right back there. So if I move it and reset it, it goes right back there. Reset it, it goes right back there. Okay. The program, the homework assignment uses relative coordinates. So if I move it and I reset it, it goes back to the center of the screen. See how he stays at the center of the screen? That's kind of a nice feature. You know, the drawing always is going to be centered in the screen. Now that means the drawing gets chopped off, but the other one chopped off too. The other one just chopped off in a different way. Here, see, it's going to chop off anyway. It's going to chop off anyway. Yeah, if the screen's now, what's the other possibility? When the screen shrinks, what else could I do? Shrink the whole picture to fit in the window. That's actually a little bit harder to do. So there's a lot of things, there's a lot of things you could choose to do. This one is using absolute coordinates. So when you do this, you just chop the picture stays put and you just chop off what isn't visible. This one uses, the new one uses relative coordinates. It keeps the picture at the center, but it chops off what doesn't fit. A third possibility would be that as you resize the window, the drawing would scale down to fit in the window or scale up to fit in the window. Different programs do this different ways. If you pay attention, you'll see that like, let me show you an example of that. Can I save this picture? See, what does Irfan view do when I do this? Chops it off. Okay. Now, open that same picture in a different program. What am I using now? Chrome, right? What's Chrome do? See, they chose different strategies. Okay, now this is Microsoft's photo viewer. This is Chrome. And this is Earth View. Notice how Earth View chops. Chrome scales. Windows Photo Viewer also scales. But Earth View is Chrome's a little bit weird. See, notice that this picture is bigger. See, the picture's been scaled down, right? When you hover over it, you get a little magnifying glass. That means I've scaled this thing down for you. Click on it, and it does what? It reverts it to its regular size, and now it scrolls it for you. So that's a third strategy. Okay, notice I've got three strategies right now. Scaling, scrolling, or chopping. But infrared is also scrolling if you wanted to. See, there's the scroll bars. Okay. Your homework, I mean, the same thing is true of you're drawing graphics here. This thing could have done any one of those. Right now, it's doing the chopping. When you scale the window, you just chop off what doesn't fit. A harder homework assignment would have been, when the window scaled, you would have to resize the picture to the right scale. That's actually a little bit more work. Especially for this one, that would have been more work. But this is more work than what the other version did. The other version just didn't pay any attention. It just plotted, it just used absolute coordinates. So everything is drawn absolutely. Now, here's where that trail is going to, this debugging thing is going to help you. Okay, let me reset this and reset this. And okay, let me clean up over here. Okay, now the focus is on the dot. Well, actually, I want to turn on debugging output. Clear everything. Okay. There's where the dot is. Look at his coordinates. He's not at 300, 300, which is where he really is. As far as I'm concerned, he's at the origin, 0, 0. So I'm storing, so you notice what I called it. It's a hint. The delta X and delta Y is how far away are you from the current origin, the center of the universe. Right now, he's sitting at the center of the screen. So I'm storing the fact that his delta X, delta Y is 0, 0. Now, if I use the up arrow key, see that new dot is 5 units above the center of the screen. Okay, and it doesn't really matter if you think of it as negative or positive. It doesn't really matter which one is the negative axis and which one is the positive axis, as long as you're consistent. Like right now, I have negative X going that way, positive X going that way, positive Y going down, and negative Y going up. That's because in this graphics window, 0 is up there and positive Y goes down. So I just go ahead and I'm going to stay consistent with their point of view. In algebra, we have positive Y going up, but in the coordinate system of the graphics window, positive Y goes down. So now that dot's 1 is 5 steps above the origin, so it's -5. Okay, and another. See, now he's 10. So now the history's got 3 dots in it. the original dot, then 1, 2. So there's 3 dots in the list, and they're going. Then if I hit right, this dot is 5 units to the right of the origin and 10 units above the origin. Now, if I rescale the window, there's actually a little bit of bug in my program. Well, no, actually, what happened? What happened there is every time I resize the window, I'm adding new things to the history list. I probably should be clearing the history list and then adding things. But right now, a bunch of stuff is piling up in the history list. So I think I've got redundant stuff in the history list. I didn't have time to sort all this out. So my program is probably putting too many things in the history. It's probably the same point, well, so you can see it here. See how the same point's being put in the history list over and over and over again. It's kind of redundant. It makes it inefficient. If I clear the history list, then I can go, get rid of all that, okay? So the program is a little bit sloppy. My version of it is a little bit sloppy. I'm not being as optimal as possible on what I put in the history list. But the key is that the history list is the delta X and delta Y relative to the origin. So that when you rescale the window, see, that dot is moving, right? But its coordinates aren't changing because he's always at the center. So now, how do you know if a window changes size? That is called a component listener. So here, a component listener is a thing that listens for changing of window size. Now, in fact, the component listener listens for several things. The component listener listens for 4 things, 3 of them you don't care about. It listens for when the window is hidden and shown. So this is when the window gets shown after hidden, you don't care. This is when the window gets hidden. Okay, so your program is told when the window is hidden. Your program is told when the window gets shown. Those don't matter to us. So you just leave the implementation empty of those 2. You're told when the window moves. See, that's just this stuff. Well, we don't care about that either. We care about this one. When the window resizes, you're told what the new dimensions are. So you have to write this method here. Component resize. Now you have to write all 4 of them, but you give empty implementations for the other 3. This is the one you have to worry about. Okay, so that's going to be part of the state of your program. The new program needs to keep track of in the state for the program. It's going to need to know what the current size of the window is. If you know the size of the window, you know where the origin is. The center of the window is width divided by 2, height divided by 2. Half of width and height is the center. So whatever the width is, half of it's the center. Whatever the height is, half of it's the center. So if you know the width and the height, you know where the center is. If you know where you don't have to store. You don't have to store both. If you store the width and the height, you know where the center is. If you store where the center is, you know what the width and height are. But if you want, you can store both the width, height, and center, whatever. All right. But the key is that in your history list, you should store the dots should be stored relative to the center of the screen so that you can redraw them relative to the center of the screen. When the screen reshapes itself, that thing stays in the center. See, the dots staying in the center all the time. And if I draw like this, see, that'll stay in the center. In the other program, if I draw this, see, it just stays where it is. So if I do this, it's still there. It thinks it won't paint itself until there's room for it to paint. The history list remembers where those are, but the history list is trying to paint off the edge of the screen, and then nothing paints off the edge of the screen. So Java doesn't, Windows, it's not an error to paint off of your screen. There's no error. It's not like an array. What happens when you go off the edge of an array?
Create an error.
Right, but not when you paint off the edge of a screen. And that's actually kind of on purpose, just for reasons like this. Why throw errors when I'm painting off the edge of that screen? No, just don't paint anything. Okay, so it's not an illegal operation to paint off the edge of a screen. So my program actually is doing that. My program is painting off the edge of the screen, and what's called clipping. In graphics, this is referred to as clipping. You clip off anything that's drawn off of the edges of the screen. They're just thrown away. They're clipped. We say they're clipped off, but they're still there. So when the screen gets big enough, they start showing up. Now they're not clipped off. Now they're clipped off. Now they're not clipped off. The program you're doing though is not. It will clip if the screen just gets too small like that, but it keeps the drawing at the center of the screen. Okay, that's the trickiest new feature in this one. That's the biggest change between the last one that we did in class and this one. This different coordinate system is probably the hardest feature. Yeah, the other parts are just adding event listeners. So most of this other, like this is just a few lines of code. The combo box up there is just a few lines of code. It's not, you have to look up how to do it, but it's not much. But this feature here requires you to make a lot of changes. You have to go back and think real clearly about what it means to store the coordinates of these dots. And you have to shift from one coordinate system to a different coordinate system. Okay. Now, actually, you do not have to do what I'm doing. You could store the absolute locations, not the deltas, but then you'd have to do more bookkeeping. Then you'd have to store the absolute location and the current center so you can compute the deltas. So you don't have to do it the way I'm doing it. This is probably the most direct way to do it, but you could store the absolute location, but then you'd also have to store with it what the current center is so that you can compute the deltas. Okay, so this is probably the easiest way to do it. Just store in the history list the delta X, delta Y relative to the center. Okay, I think that's it. I think that's all the advice and ideas that are in this thing. Again, your starting point is this folder here. Yeah, that's, about half that, almost all of that code is usable. The only thing that's not usable is you'll have to change the coordinates of the, you'll have to rejiggle the stuff that saves X and Y values. But most of what's in there is just reusable. You're going to add about 7 or 8 more event listeners. Yeah, so you're going to add event listeners for, you'll need new event listeners for this combo box and all these down here. So you'll need the resize event, the component listener. So you need an event listener for the resizing. That's one new event listener. That's one new event listener. This is a second new event listener, a third one, a fourth one, a fifth one. So you need at least 5, you need about 5 or 6 new event listeners. And then you'll need to add a lot more code to the main method. The main method that adds all these things up, this is the program that's building all the components and adding them to the GUI. So this is just going to get longer. You'll be adding to this and change the name. This thing will change the name of this to homework 2. Get rid of that long name. So you'll name your new program is going to be called homework 2. You can leave all the other files. You can give them any name you want. If you want to rename the classes, but name the main class homework 2. That way I can, if everybody gives it a different name, I'll have a heck of a hard time running your programs. If you all name it homework 2, I can write a script to run your programs and test them much easier. So the one that holds main, the class that the top level class that runs everything else should be, the one that holds main should be called homework 2. So that's just this, what was called circle program with mouse button sliders and checkboxes. Okay, so start with that. And the other files, I don't care if you leave them the same name or if you change any of their names. It's up to you whether you want to, if you like those names, go ahead and keep them. If you want to give yourself names that help you think about what they do, you can change the names of them, okay? And so, and then what you're going to turn in is your homework2.java and all your other files, okay? So you'll send a zip file. My version has about 15 or 16 files altogether, okay? My solution is about 15 or 16 files. I can't remember what, like right now. What do we got? We've got 13 already. Yes, actually, probably mine's more than 15 or 16 because we're already at 13 and you have to add a bunch more handlers. So maybe you go up to 20 files. Some of those files are literally 5 lines long. You're not writing 15 files of 100. The whole thing is just a few hundred lines of code. The whole thing, when you're done, should be no more than 300 or 400 lines of code. It's not a lot of code. It'll be spread out over 20 files, but many of those files are just 3 or 4 lines. They're just real simple little event listeners that just get an event and store a value in the state object. So even
some things that are used to store like 3 variables at once.
Yeah. So I mean, even these, some of these were really simple. Dot state is just stat. Well, let's see. Oh, that one's unimplemented. That's not the that one we never finished. But here, this is 1 line of code. The real work, just that 1 line of code. The rest of it's boilerplate to set up the constructor. There's actually only 1 line of real code in there. The rest is boilerplate code. In fact, some IDEs can generate all that boilerplate code for you automatically. The only real line of code is that 1 line there. Okay. So you're going to write stuff like this. You need an event listener. It needs to know where the state is. It needs a constructor to tell it where the state is. And then it has to override this method. And then there's 1 line of code in the method. So out of how many lines of code there are in there, I thought I turned in line numbers. So out of 17 lines of code, 1 is significant. Java's got a real high ratio of this. This is really like a typical feature of Java. Lots of boilerplate code, but the boilerplate code is not, Java programs are readable. And some people don't like it that there's so much boilerplate to Java, and other people think it's actually a benefit. It gives you something to think about. It has advantages and disadvantages. There are languages like Haskell and some other languages out there that are famous for just like, this whole file would be 1 line of code. You wouldn't need any of that other boilerplate. But that can also end up being cryptic.
Yeah.
It can go both ways. So Java's famous for being really verbose. 1 line of significant code to 16 lines of boilerplate code. Lots of braces, lots of punctuation, but on your hand, it has, it's a trade-off. It's a trade-off between readability and now. Oh, here's the thing. 17 lines of code are 17 places to make mistakes. And you do end up goofing up a semicolon here, a misspelling here. And that's what some people complain about. When you have 10,000 lines of code and 4,000 of them are boilerplate, that's 4,000 places to make mistakes that really shouldn't be there. So the Haskell people say, we don't have 10,000 lines of code with 4,000 lines of boilerplate. We have 6,000 lines of code, and it's all significant code. There's no boilerplate. So if you've got a mistake, it's going to be in your real logic, not your boilerplate. So it's a trade-off. You goof up something, you misspell a variable name here. You could be surprised how the compiler may not catch that. You misspell a variable and it happens to be spelled the same way as some other variable, CS1, CS2. And you call CS2, you use CS2 where you meant to use CS1. That can cause all kinds of hard to find errors. Okay, so boilerplate can be good and boilerplate can be bad. Java's famous for the amount of boilerplate that it has. And this is a real good example. 1 significant line of code out of 17. And that's not the only one in here. If you go through these, you'll find more like that. here's 2 significant lines of code out of okay, out of 20 lines, only 2 are significant. Those are the only 2 that do anything. The rest is boilerplate. Okay, yeah. So the ratio is not as bad here, 2 out of 20 versus 1 out of 17. But you can still, the significant, the methods only got, this one has 2 lines of significant code, the other one had 1 line of significant code. All the rest is boilerplate. You're going to be writing a lot of, you can copy and paste the boilerplate. That's, if you remember, that's how we were doing these in class a lot of times. We were just copying and pasting the boilerplate, change a couple names, and now you have a new method. Okay, so you get kind of used to this when you're doing this, especially this style of Java programming, writing a lot of these event listeners. See, you're writing a lot of things that implement action listener, item listener, checkbox. So you're implementing these listeners. They all have the same, every listener has more or less the same shape, but there's just some little detail that's different in each one. Okay, so you're not going to write a lot of code, but you have to think about it. You have to be aware of what you're doing when you write these things. So start with these and maybe rename this stuff to make it, if you want to rename it to make it look to give it names like you prefer, and then just start adding event listeners. Go over here and try to think about what's the easiest thing to add first. Okay, try to do the easy ones first. Okay, the hardest one is the relative, but actually you could do that first if you want. If you do the relative one first, you'll have less things to change when you go back and fix it. If you do all the other pieces and then do the relative part last, you'll end up changing some things you just wrote, but it's not that bad. But it depends on, if you think you can do the relative, you can do that first, and then you'll have everything set up to do the relative positioning. But if you want, you can go and do these other things that are easier, but then you'll find that when you go add the relative code, you'll be changing some things you just wrote, but not big changes, but you'll be changing something you just wrote. So either add the easiest things first, or just, if you want, jump in right away and try to make this thing have the relative coordinates. So put this in first, because this will help you debug what you're doing with the coordinates. Because then you can just, it's really helpful to be able to see the coordinates. I don't remember which one was which there. It's just real helpful to see those coordinates. So if you're messing up, you'll see it here. If you're storing the wrong coordinates, you'll see it in your output. Okay. Okay. Any question? Let me clean up a little bit. Anybody got any question about this? Okay. The next thing we're going to do is we're going to start talking about this OpenGL. We're going to switch from GUI programming to 3D graphics programming. Then we'll integrate them together. Now that we've learned a lot about checkboxes and buttons and things like that, we can make use of them when we're writing some GUI graphics programs. But we're going to switch to doing 3D graphics. Now, we're going to use this thing called Joggle. Unfortunately, not a lot of people, this is Java OpenGL. OpenGL is the standard. All the games you play are written in OpenGL. The Java interface to OpenGL isn't used that much anymore. Most people, if they write games in OpenGL, they write them in C or C++, or Python or C#. C# has actually become really popular for writing games because of Unity. And people also use JavaScript because there's a web interface to OpenGL called WebGL. So right now, heavy-duty games are written in C++. Online games are written in JavaScript, usually. And some people are writing games in C# and using Unity. Okay, almost, maybe I can say nobody is writing games in Java anymore. There was for a short period of time. There was a little bit of a game industry in Java for a short period of time, and it used Java, but that was like 15, 20 years ago. So Joggle still exists. It's really nice. It's very elegant because Java is a nice language, but there just isn't a market for it. So that means that the information is old. Like these, I think, I'm not even sure if we can use these. These are, well, this one's maybe too old. This one seems to be pretty good. Okay, here's what these are. Purdue Cal has a license with a publisher called Springer Verlag. We have a site license to their books. And if you're on campus, you can download their books. So see, I can just download that whole book. See, it's 585 pages. On campus. If you're off campus, this won't work. If you're off campus and you go to this page, you'll be asked to pay for the book. So be careful. I'm not telling you to pay for these books. It says on the website, when you're on campus, when you're connected to the campus network, you can click on these. If you click on them from off campus, you'll get a price tag on them. If you click on them from on campus, you can just download them. Now, one thing, this is set up kind of nicely. You can download the book, or you can download individual chapters. So like right now, the only chapter we're interested in is one on Joggle. So you click on PDF, and there's the 10-page chapter on Joggle. Okay, so you can just download the chapter that's relevant to what we need, and you can read it on your computer. You can print it out, whatever you want, save it. Okay, so you can just print out the chapters that you're interested in. Now here's another book that's the same thing. It's a same publisher. You can see how dated this is. Pro Java 6. Java 6 is from like 15 years ago. That's when there was a little bit of a market for 3D games. When this guy wrote this book, there actually was a game market, but that's like 20 years ago. Okay. There's a introduction to Joggle. What chapter is it? It's down here. Here. It's way down here at the bottom. It's at the end of the book. So there's an introduction to Joggle right there. All right. So that's the chapter I think you might want to look at. And I'm not positive that this stuff is usable. I know that we're gonna have to make adjustments because so much stuff has changed in the last 20 years. So we'll have to make adjustments. And I'll show you a little bit. I got some of them already made. So like class paths are changing. Okay. But the general point of view is correct, but the details, some of the details are incorrect. Okay. Now, the guy that wrote this book has a website where he's updated that book. And he's got some very good stuff on this website. Okay, so this is the website of the guy who wrote that book. I'm going to put a link to this a little bit later, but let's see, where is it now? Here. Here's his homepage. He's created a library he calls Simple 3D that makes it real easy to use Joggle. Okay, so I just realized this last night that he's actually keeping up with this stuff. So this is real recent. This was just done in the last year or two. So even though Joggle's kind of old, so here's what he has: installing Simple 3D. Okay, so you download this zip file. I'll put a link to this. And the Joggle libraries with a lot of sample code are in the zip file. But there's one problem. He's not writing Joggle code. He wrote a library on top of Joggle and he uses his library. So he's not actually writing code that uses Joggle. He's writing code that uses his library he wrote that's written on top of Joggle. So there's all kinds of great examples in here. But the thing is, the advantage is it makes it easy to use Joggle. Okay, so I'll show you what I mean by that. Okay, so here's his library. Okay. He's got all these examples. So for example, you take this earth.java, you drop it onto the compile file. Okay, that just compiled earth.java. Now you take it and drop it on the run file. There's a little spinning globe.
Oh, wow.
Yeah, it's real nice.
Really detailed too.
Yeah, well, that's a texture.
Yeah.
Yeah, it's just let's see. Where did that come from? Images, earth texture. See, we're going to learn. See, there's the detail. You wrap that picture around the sphere, and that's what makes the sphere look detailed. That's the whole trick. That's called texturing. You take these pictures and you wrap them around images, and then you think, wow, how did you get a globe that detailed? Well, you just take a picture of the earth and wrap it around a sphere. Okay, and he's also got a picture of the sun in here. So he could wrap a picture of the sun around the sphere and get a sun. Okay, and he was supposed to have a picture, oh, he's got the moon. And he was supposed to have a picture of Neptune and it's missing. I might write him an email. The picture of Neptune is missing. So let me show you. There, see this gaseous planet? See gas giant planet? Compile it. Run it.
You got the Java one. The-
No, you run the Java one.
Oh, that's
Yeah, and okay. See, the texture's missing. But look, see, error message. I know it does look like that. But see, there's the error message. The input file's missing. He's missing one of the texture files. The one that's supposed to wrap around this planet is missing. Okay, so he's got, he somehow lost one of the, then in here are a bunch of 3D models, a spaceship, a robot, a penguin. So he has a bunch of 3D models. These are like, if you took the undergraduate graphics class, these are the same models we were using in the undergraduate graphics class. They're these OBJ models. Okay, so there's the model and there's the texture for the model. That'll be painted on the penguin model. In this way of doing things, the shape and the texture are stored separately. The shape is stored as what's called an OBJ file. Oh, I opened the wrong file. There's the data. A penguin is nothing but a bunch of points. Vertex, 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 vertex. V for vertex. Vertex is just another word for point. This is just a data file showing that these are all the points that make up a penguin. And there's going to be thousands and thousands of them to make up a penguin. So this is the geometry data of the penguin. And then the appearance of the penguin is in a picture. And then that picture gets wrapped around the geometry. That's what we'll be looking at. Okay. So he's got a whole bunch of examples of this in here. He's got lots of models, a car, a bird. Okay. And let's see. Now, but the code here is not OpenGL code. The code here is his library, which he calls Simple 3D. And I don't want to use Simple 3D. I want to use OpenGL, Joggle. Okay. So let me show you. But it turns out you can use this setup of his. So I wrote a real simple OpenGL Joggle program. Right now it's on my home directory. I didn't put it up on the website yet. So it's on my H drive. So here's a little basic Joggle program that I wrote. So I'm going to take that basic Joggle program and dump it in his folder. Now I'll compile it with his compiler batch file. And I'll run it with his run file. And it draws one line. Okay. So now I've got a Joggle program running. Now what's the Joggle program running look like? Here's the basic outline of a Joggle program. Now we'll have to talk about this as we go along. A Joggle program is an implementation of what they call GL event listener, which is weird. We use event listeners for listening for events. Here, the program is itself an event listener. And this is the inversion of control idea that I mentioned. This is inversion of control on stereo. It's actually not really an event listener. It's really the idea being you write the functions and I'll call them. Joggle is going to call our functions. So we write functions that Joggle calls. So we're using an inversion of control system, what people sometimes call a framework. So we write 4 methods. And the 4 methods are init, which sets things up, display, which draws the thing you want to draw, reshape, which handles when the window changes shape, and dispose, which is for cleaning up. If you have things, if you want to clean up when the program ends, you can put almost nobody puts anything in here. Yeah, most people just, when their program goes, they just let everything get garbage collected. But if you want this is where you could save things and stuff like that. So you get an init method, a dispose method, and then the real workhorse is this draws, and this handles the changing shape of the screen, like your homework assignment is. Those are the 4 methods that make up a Joggle program. Okay, so you write a program that implements those 4 methods. Then, how much time do we have? Oh, I thought I said assignment. Okay, you basically you create a GL canvas and you put it in a J frame, and then the J frame holds the canvas. So this is like very much what we've been doing before. See, here's the Java GUI stuff right here. But what we're doing is, instead of creating a panel, we're creating a thing called the GL canvas. The GL canvas knows how to talk to the GPU. So the GL canvas, so instead of using a Java panel, a J panel, which doesn't know how to talk to the GPU, we're going to use this thing called the GL canvas, which is part of Joggle. This guy knows how to talk to the GPU. So when you draw on this canvas, instead of drawing on a panel, you're drawing on a canvas, and the real drawing is being done by the GPU. So the canvas just sends all the information to the GPU, and the GPU very quickly runs your code. So that's the idea. This replaces our panels with a canvas, and then the rest of the stuff draws on that canvas. So that's where we'll pick up. I'll put this up. Notice you have a whole bunch of imports. This is import. One last thing. Here's where the imports come from. A bunch of jar files. So you have to put all those jar files in your class path. The trick is you got to put all those jar files in your class path. And that's what he does in his little batch files. His little batch files are clever about putting all those jar files in your class path in a tricky little way. Notice the class path. But he's got I've never seen that trick before. I didn't know you could do that. And I think that trick is new. I think that trick is a new feature of Java 11. You can put stars in your class path. So he writes this real simple. Used to be you had to write a class path where you had to say this jar, this jar, this jar, this jar, this jar. And it was a real pain. But I think this, he says release 11. I think this is saying this, you need Java 11 or more recent. Then you can use this fancy class path. So he sets up the class path, and then you can, but the library is right there. This is the Java library. Okay. So it's all bundled in this simple 3D program. So this simple 3D bundles it all together. So this, I think at least for get started, we'll just use this simple 3D because it's all bundled together. Plus it's got these neat demos, but the neat demos are not Joggle demos. They're his library demos, which he wrote on top of. So in that zip file, in that library, not all of it's Joggle. Some of that's his stuff. Oh, well, this one would be his stuff. Yeah, that one's his, the others are Joggle. That jar file is his, the other jar files are Joggle. Those are the ones we're going to use. Okay, so we'll quit there. Okay. Severe weather. Oh, they're closing again?
Yeah, tomorrow.
What day's tomorrow?
Tomorrow.